If you've ever been on an airplane, you know the feeling. We've all been there, right? You're taking off, or maybe you're landing, and you get that weird, uncomfortable pressure building up in your ears, and then pop! It's this universal thing for anyone who flies, but what is actually going on? Well, the answer is this really cool mix of human biology and aviation mechanics. So, let's start with the first part of that puzzle, the pressure inside your own head.
But for some people, it's way more than just a little pop. It can be genuine, intense pain. I mean, this quote from travel expert Nora Dunn, wow. It just perfectly captures how bad that discomfort can get. And if you've ever been that person on a flight, trying anything to get some relief, you know exactly what she's talking about.
So what is the science behind this whole thing? Well, this feeling actually has a name. They call it airplane ear. And honestly, once you understand what's happening, you're already halfway to fixing it.
Okay, so at its core, airplane ear is really just a simple physics problem. The air pressure inside the airplane cabin is changing way faster than the air pressure inside your middle ear can catch up. And the key player in all this is a tiny little channel called the eustachian tube. It's supposed to act like a little pressure release valve, but sometimes it just can't keep up. So here's what's going on. When that pressure doesn't equalize, your eardrum gets sort of pushed inward or sucked outward, and that's what causes that full feeling and makes everything sound muffled. And this brings us to a really important warning. If you're flying when you have a cold or bad allergies, your eustachian tubes can get inflamed and blocked, and that can turn simple discomfort into severe pain. And in some really rare cases, it can even lead to a ruptured eardrum.
All right, so how do you fix it? You've probably heard of the most famous technique out there. You might have even tried it yourself. It's called the Valsalva maneuver, and it's used by pretty much everyone, from scuba divers to fighter pilots, to manually force that pressure to equalize. Now, the process itself sounds super simple, right? You're basically just creating pressure in the back of your throat to push air up through those little eustachian tubes. But the most important word on this entire slide is that very last one, gently. Because as easy as this sounds, if you do it wrong, you can cause some surprisingly big problems.
And here is exactly why you have to be so careful. If you blow too hard, you can actually damage the really delicate parts of your inner ear. This maneuver can also mess with your heart rate and blood pressure for a second. So if you have a heart condition, this is one you should definitely talk to your doctor about first. The key is gentle and brief.
Thankfully, the Valsalva isn't the only trick up our sleeve. In fact, for a lot of people, there are much simpler, more natural methods that actually work even better, and they come with way fewer risks.
Hey, remember when flight attendants used to hand out candy before the planes started to descend? Well, there was a real scientific reason for that. The simple acts of chewing and swallowing actually activate the muscles that pull your eustachian tubes open. A big yawn does the same thing. And here's a big one. Just stay awake. You don't swallow much when you're asleep, which makes it way easier for that pressure to build up without you even noticing.
Here's another specific technique for you. Kind of like a hybrid approach. It's called the Toynbee maneuver. You pinch your nose, just like with the Valsalva, but instead of blowing out, you just swallow. For some people, this gentle pulling motion is way more effective and feels a lot safer than the forceful push of the Valsalva. So, we've figured out how to manage the pressure in our ears. Problem solved, right? But hold on. When a pilot and a maintenance chief are talking about equalization, are they always just talking about popping their ears?
As it turns out, in the professional world of aviation, the word equalization has a second, completely different, and absolutely critical meaning. And this one has nothing to do with eardrums, and everything to do with keeping the plane itself safe and up in the sky.
And this right here is the big aha moment. Just look at this. On one hand, you have the physiological equalization we've been talking about, balancing the pressure inside your body. And on the other hand, you have equalized maintenance, which is all about balancing the maintenance schedule for the machine itself. Two totally different problems, one simple word.
So let's dig into this second meaning. Think about it as managing a totally different kind of pressure. The huge logistical and financial pressure of keeping a whole fleet of multi-million-dollar aircraft flying as much as humanly possible.
So the old way of doing things was you'd take a plane out of service for weeks at a time for a massive heavy check. Well, equalized maintenance completely flips that idea on its head. Instead, you take that one giant inspection and you break it down into dozens of smaller packages that can be done overnight in just a few hours.
And the reason for doing this? It's all about economics. An airplane doesn't make any money when it's just sitting in a hangar. So by using an equalized schedule, airlines can keep their planes in the air generating revenue, with almost no disruption to their flight schedules.
It's all about maximizing that availability. But this approach isn't a silver bullet. It's a trade-off. The pros are huge, right? The planes fly more, mechanics get steady work. But the cons are very real too. It can end up being more expensive overall. It involves a lot of repetitive work, like opening and closing the same panels over and over. And if you don't manage it perfectly, constantly working on the plane can actually increase the risk of maintenance mistakes.
And that brings us right back to the beginning. Whether we're talking about the delicate membrane in your ear or a complex jumbo jet, the whole concept of equalization is about the exact same thing. You're proactively and carefully managing pressure to prevent a small problem from becoming a massive one. One prevents pain, the other prevents operational and financial disaster. So, the next time you hear a simple, everyday word, especially in a technical field, maybe pause for a second. It just makes you wonder, what other complex worlds are hiding in plain sight, just waiting to be discovered?